Now we will be knowing about hydrostatic paradox. It is a thing which is not specifically mentioned or taught in any other source or material or book or whatever you want to call it. They do not mention about it and they do not teach it, but it is something which if you do not know, then you may get confused while solving a question, maybe in GATE or maybe elsewhere. To make you understand what this hydrostatic paradox is, I will firstly give you an example, then I will give you a question, and then I will explain you what this paradox is, okay, and how to overcome this paradox. Okay, so suppose we have a dam. Okay, we already know how much large quantity of water, gallons of water, is held in the reservoir of the dam. So this is the structure of the dam and a lot of water is stored in it. Okay, the pressure or the force which is felt by this structure due to the pressure of water will be defined by rho gh at any particular point. So let's say the pressure at this point we want to know, and this is point A. So pressure at point A will be rho g h, right? Consider one more structure exactly similar to this one, the structure of dam, but there is not so much large quantity of water stored. We have just a very thin reservoir, just few liters of water is stored here. Okay, both of them are having the same height, exactly the structure is exactly the same. In this case we were having, let's say, a lot of quantity of water, and in the other case we just have few liters of water which is filled in a small gap between that. The chances of failure of this dam are exactly the same as the chances of failure of this dam, because the pressure or the force felt by any particular point at the same depth of h, so that pressure will still be rho gh. The area of dam is still the same, so the force felt will still be the same at that particular point. So in reality this is going to happen, but if you just think about this idea, you may get confused or you will have two conflicting ideas that how is it possible, it is so much of water, it's holding that much large expense of water and it is just holding few liters of water. Obviously this will be very safe, no pressure force would be felt, means the pressure force felt at A will be less here as compared to that one. Or if you don't talk about pressure, if we just talk about the force, then anyone will say that this will feel more force as compared to this, a general statement. But concept wise, in reality both of them are having equal chances of failure, because pressure at that point is rho g. This is hydrostatic paradox. We tend to see something, then we make some conclusion from it based upon our general beliefs, right? But when we look at the concept, then that gives us some other conclusion, and both of these conclusions from general observation and from the concepts or from the Pascal's law are giving us two contradictory conclusions, two different conclusions which are not matching up with each other. That is a paradox. Okay, this was a general example that I give you. Now I am going to give you an example which will actually confuse you in GATE. Okay, let's see that. Now look at this question. In this question we have a container of a particular shape which has two different cross-sectional areas. At the bottom side it has a cross-sectional area of capital A, at the top side it has a cross-sectional area of small a. Okay, this height is small h and this full height is capital H, and the question is asking you to determine the value of force acting on this bottom area capital A. Okay, it is a question from GATE, it's a previous year GATE question. Now whenever some student look at this question, there are two types of thought that can come to his mind. Some of the students can think that the total force on this horizontal plane will be equal to pressure on that plane multiplied by the area. Pressure is rho g capital H multiplied by area. So this is going to be the answer. Okay. Some of the students may think that the weight acting on this area should be equal to the weight of this fluid, right? If some person is sitting on on a particular area and I ask you what is the total force on that area, then total force on that area will be weight of that person, right? So same thought can come to your mind and you can think that the weight of the fluid should be equal to force on the bottom area, which seems very logical. Okay, so force should be equal to weight of the fluid. Okay, so let's try to come to an expression for weight of the fluid. If I show you this same diagram in 3 dimension, then it will look something like this, right? This volume, full volume, minus the volume of the void where the fluid is not present will give me this volume where fluid is present, right? This area is capital A, this area is small a, this whole height is capital H, this height is small h, right? So total volume of this cylinder, even those volumes where fluid is not present, will be equal to area multiplied by height, capital A multiplied by capital H, let's call it V1, and V2 is that volume of that void where fluid is not present, the volume above this shaded area, right? So this area is capital A minus small a multiplied by H, so that will give me the volume of the void. So capital A minus small a multiplied by small h, right? Now coming to the weight. Weight is mass multiplied by G. What is mass? Mass is density multiplied by volume. So total weight of the fluid is equal to weight of the bigger volume considering the whole volume minus weight of that volume where fluid is not present, and not the actual weight, the weight if fluid was present there, right? So from the whole volume we will subtract the volume, or from the whole weight we will subtract the weight, and we will get this weight of the fluid. So total weight is going to be rho, total volume G, minus that weight where fluid is not present, so that is rho, volume is A minus small a h multiplied by G. So this is the force due to weight of this shaded fluid on the bottom area, right? So these are the two things that can come to the mind of a particular student. It may be possible that some of you can just think about this and move to next question. It may be possible that some of you may think about this and move to next question, right? Obviously one of them is correct, both of them are different. How? This is rho G A H, capital A capital H. This is also rho G A H, capital A capital H. But we have something subtracted from this. So this value is less than that value. So obviously both of them are not same, both of them are different. So which one of them is correct? Look, the force, this one, is a value which is more than the weight, because weight is when you subtract, means from this expression you are subtracting something, so obviously this is less, this is more. So if you think logically, then the force due to pressure at the bottom area is even more than the actual weight of the fluid. It is, some of you may think it just like the case that if I am standing on a surface, on an area, then the force exerted by me on the bottom surface is even more than my weight. So how can you justify that, right? There will come the confusion. Now there will be a contradiction. The logical one is saying this is the answer, but when you apply the hydrostatic law, then this is giving you the answer. That is again a hydrostatic paradox. Which one to pick? Which of them is correct? If I tell you, or if we go by the previous case of the dam where I explained you, this should be the correct. But it does not feel right that why weight should not be equal to the total force. How will this be justified? Let me show you how will this be justified. This is the FBD of the container, right? This container in which fluid is kept. What we are doing, we are just considering the pressure on the bottom area due to the fluid pressure. Let me draw it here only. We are just considering the pressure on the bottom area, right? But we also know that whenever a fluid is in contact with the surface, it exerts some pressure. On every surface it is exerting pressure. It is also exerting pressure on this surface, on this surface, on this surface. Since we are more concerned about the forces in vertical direction because we want to know the force on A, so this we are not considering. But why not this? Why will not we will not consider that? That is also an pressure acting on the surface. That will exert a force in the upward direction. So the net force acting in this direction, in the upward direction, due to this pressure is how much? Pressure up or force in the upward direction is equal to pressure in the upward direction rho g small h multiplied by that area, this area on which that upward pressure is acting, which is capital A minus small a. What is force in down direction? Rho g capital H a. Net effective force in the downward direction, net in the downward direction is rho g capital H a minus rho g a minus a h. Now compare this one with this one. Any difference? Both of them are same. From hydrostatic law also you are getting the same expression of net force as you are getting from this one, right? The only confusion that you were having or you might be having, that you are just applying the force, the hydrostatic law for the bottom surface. If you apply that law for the whole container in vertical direction, it will match with the weight, and that's where the problem comes, that this thing will not necessarily come to your mind in the pressure of the exam, right? So there are two things to learn from whole this story which I told you. The first thing, that whenever you are in a state of confusion in such a cases where you have multiple surface, multiple shape, if it was just a simple setup that a surface is there and the water is there above it, then obviously the force will be equal to weight of that water, no doubt in that. But whenever you have such setup where there are multiple surfaces, then be careful about choosing what force that you will take as the final force. In case of confusion, always go with the hydrostatic law. No matter, it may feel you wrong, but that will give you the correct answer. First thing. Second thing is that whenever you have a case where there are multiple surfaces, always keep it in your mind that pressure will act in all the directions. I know we have a tendency, we have a feeling that weight will act in the downward direction, forces will act due to downward direction, means due to this fluid, but make it an intuitive idea in your mind that this fluid is exerting pressure in all the directions, everywhere. Wherever there is surface and fluid is in contact, it will exert some force no matter what is the relative orientation.
Now, if you look at this question, the question is asking force F which is needed to support the liquid of density D. And if you look at the diagram, the force F is acting at the bottom piston, bottom frictionless piston of area capital A, right? So you only need to find out the force that you need to apply on capital area A. And to know the force which is acting on any particular area, simply apply the hydrostatic law as I told in the video. The reason I explained this hydrostatic paradox was that some of the students can get confused that why not to take the whole weight, because if you equate the weight of the liquid to the force acting on the bottom piston, you won't get the correct answer. That is why I explained you the difference between the total weight of the fluid and hydrostatic force acting on the bottom surface. Whenever the question is asking about force on any particular surface, do not try to apply your logic of weight and all. Always go by the hydrostatic law. Simply the question can be solved by hydrostatic law, and the answer that you will get is option B, because option B has pressure acting on capital area, capital A area, which is density D multiplied by G multiplied by capital H, that is multiplied by capital A to get the force acting on that particular area. So option B is correct for this. So to maximum students, this question seems very easy because they simply applied the hydrostatic law and get the answer. The idea of weight does not even come to their mind. But suppose this idea came to your mind in the exam, then you will get confused. You won't be knowing that why weight is not coming out to be the same as option B or equal to F. So that is why I have explained you the difference between these two. Do not get confused between them ever again.